Hello everyone, my name is Daniel Schuch. I work at Northeastern University as postdoc research associate with the Dr. Yang Zhang group. And in today's talk, I will introduce the response of ozone to changes of emissions under the representative concentration pathway 4.5 scenario over Brazil. So this is the outline of today's talk. So before I start, I want to show a quick background. More than 90% of the world's population do not breathe clean air. So we have primary pollutants, are pollutants directly emitted to atmosphere, and we have secondary pollutants. Secondary pollutants are a product of primary pollutants and some background concentrations at atmosphere. For example, the ozone is a secondary pollutant with high impact on the health. The ozone is a product of reactions on the atmosphere in the presence of sunlight and in the presence of VOCs, the action of NOx emissions, basically. So we want to know the future ozone concentrations, and the future ozone concentrations will depend on future emissions. That will depend on the technology, because more efficient technology will emit less air pollutants, and also mitigation policies, how these technologies will be applied on different economy sectors, such as agriculture, industrial, and also transportation sector, and so on. And also, the future ozone concentrations will depend on climate change, will depend on the future state of the atmosphere. So we have these questions: what will air quality look like in the future? So the objective of today's talk is to show how future changes in emissions will affect ozone for Brazil. So I will show some numerical results using the WRF-CAN model. The WRF-CAN model is a weather research and forecast coupled with a chemical model, so all the reactions are solved online. To run the model, I'm using emission scenarios from the project, the Eclipse project. The scenarios are made using the GAINS model. The GAINS model is an integrated assessment model. So this takes into account more than 1,000 technologies over the globe, more than 200 technologies, and also takes into account the political measures to reduce our pollutants. To use this dataset, I'm using the MSV, the R package that makes the emissions to model, and I'm also using the RCP 4.5 future climate scenario. So for my simulation, I'm using one climate scenario and three emission scenarios. My climate scenario is the RCP 4.5. This is a scenario when consider low to moderate greenhouse gas emissions, and by the 2100 the attractive forcing reach 4.5 watts per square meters. So, and I'm using three emission scenarios. The current legislation scenario is my baseline emissions. This is a scenario with the higher emissions. So in this scenario, the existing legislation of 2015 is frozen, and no further evolution of this legislation or big projects that aim to reduce air pollutants emissions. So this is a scenario with the higher emissions. For my scenarios, I have the mitigation scenarios. In the scenario, technological improvements of the key sectors is applied to many different sectors, such as transportation, industries, and also agriculture, and so on. And we also have the maximum passive reduction scenario. In this scenario, uh, unconditional implementation of technologies with the lowest emission factors. The results of the scenario is we have the lower emissions, but these scenarios also don't take into account the costs of implementations of all this technology on all sectors. So in this slide, I'm showing the total emissions for Brazil. For my three emission scenarios, the CLA is the yellow one, this red one is the mitigation scenario, and the last one is the dark bar, is the maximum passive reduction scenario. So we can see the current legislation, the emissions always increase. It's the scenario with more emissions. We have a reduction of emissions in the mitigation scenario, and we have a better reduction, even more reduction on the maximum passive reduction scenarios. But these two scenarios are not so different in total emissions. So this is my model setup for the WRF-CAN model. I'm using two nested domains, a big domain for the area of Brazil with 36 kilometers and a next domain on the Midwest region with 9 kilometers of resolution. This is my model options, and I'm using a simulation from 31 July to 10 August, plus 2 days for model spin up. Okay, I want to show some changes on ozone concentrations. These ozone concentrations were calculated using the average surface concentrations of each run. I'm comparing each sensitivity run with a reference run. My reference run is a run using RCP 4.5 and current legislation emissions for 2012 and 20. And each of my sensitivity runs, I'm using the same meteorological input and also using different emissions. In this next slide, I show you the ozone changes on my 36 kilometer domain. So in this first picture, I show you the changes for the current legislation scenario for 2050. So we have two big areas with an increase up to 3% on the ozone concentration, and the two areas on the metropolitan area of São Paulo, metropolitan area of Rio de Janeiro, with a decrease up to 10% of ozone concentrations. The next picture is the changes for the MIT for the mitigation scenario. So we have a big area with a reduction of up to 2%. And we also have the same pattern for the metropolitan areas. In the last picture, we have a bigger area. This area has a significant reduction, up to 5% on ozone, and we don't have the same pattern for the metropolitan areas. In this slide, I show you the changes on ozone concentration for my 9 kilometers domain. So in this first picture, I show you the current legislation changes, the changes due to emissions for the current legislation. So we can see that we have a big area with an increase of ozone concentration. In this area, the increase is 2%. This is consistent with the 36 kilometer domain results. So in the metropolitan area of São Paulo, we have 11% of reduction. The region of Rio de Janeiro, we have 7.5% of reduction. On the next picture, we have a big area with a very small reduction up to 1% on the ozone concentration, but the reduction on the metropolitan areas cover a better area, a bigger area, and the magnitude also is bigger from the Metropolitan area of São Paulo, we have a reduction up to 15%, and up to 11% for the metropolitan area of Rio de Janeiro. And the last picture is the reduction for the maximum effective reduction. So we don't have we have some reduction on the metropolitan areas, but the most important, we have a big area with a reduction up to 5% at this domain. So this is the comparison of the runs. I'll show you this black line is the average changes on ozone concentrations for the current legislation scenario. So we have an increase on average on all domain. This gray line is the maximum for many regions. So we have this is the worst case for your emissions, for our emissions. So the blue line is the average for the mitigation run. For we have a reduction on average of the concentrations over all over Brazil, and we also have a better improvement with the maximum effective reduction. We have, but also we have this green line showing the some concentrations in some regions still has a possibility to increase. In conclusion, the responses of ozone concentrations to emissions are non-linear and non-homogeneous, and we also many patterns of emission changes are linked to emissions from big urban centers such as São Paulo and Rio de Janeiro and the Northeast region. About the scenarios, the maximum effective reduction is the scenario with the better improvement of ozone. This improvement covers a significant area. São Paulo, Mato Grosso do Sul states present an average reduction of 4.5%. The MAT scenario, mitigation scenario, presented a better reduction on the metropolitan areas of São Paulo and Rio de Janeiro, 50% and 11%. And the current legislation is the worst air quality scenario, with an increase up to 3% of ozone with two large areas. So it's significant. So I'd like to thank you, the Master Laboratory from University of São Paulo, CAPES, and Welcome Trust. So if you have any questions, let me know. Thank you.